Welcome to this brief exploration of the cross product and its application in classical mechanics. In this video, we will delve into three key concepts: angular velocity, angular momentum, and torque. First, we look into angular velocity. An object's motion is described by its velocity vector denoted as v. This vector represents the rate of change of object's position with respect to time. In circular motion, the velocity vector is always tangent to the circular path at any given point. It represents its speed and direction. Now consider the radius vector r. This vector points from the center of the circle to the object's position on the circular path at a specific point in time. When an object rotates about some axis, the rotational angle d theta is the amount of rotation it makes in a given time dt. In circular motion, rotational angle is analogous to linear distance, and the angular velocity omega is the rate of change of an rotational angle with time. The cross product of the velocity vector v and the radius vector r is used to describe the angular motion or the rotation of the object. This concept is crucial for understanding phenomena such as spinning tops, planets in orbit, and any other rotational system. Angular momentum is another fundamental concept in classical mechanics, especially when dealing with rotational motion. A body of mass m and velocity v has a linear momentum p is equal to mv. Momentum is a vector quantity preserving the direction of motion and is pointed along the velocity vector v. Angular momentum L is a vector quantity that describes the rotational motion of an object. It is defined as the cross product of the object's position vector r and from a chosen axis of rotation and its linear momentum vector p. L is equal to r cross p. One of the important property of angular momentum is its conservation. In the absence of external forces, the total angular momentum of a closed system remains constant, as visualized here in this interactive demonstration of changing radius of the circular path. If the radius decreases, the velocity increases, and if the radius of the circular path is increased, the velocity decreases. So, angular momentum is a fundamental property of any rigid or rotating bodies. For a rigid body, L is defined as the product of the moment of inertia of it and the angular velocity. Angular momentum is a key concept in understanding rotational motion. It explains how rotating objects behave and how their motion changes in response to external torques. Angular momentum is crucial for analyzing systems like rotating gears, spinning tops. In summary, the concept of angular momentum provides insight into the rotational behavior of objects and plays a crucial role in classical and quantum mechanics. To visualize and understand more about the cross product, check out this interactive generation of vectors A and B and the 3D visualization of their cross product. When vector A and B lie on the xy plane, the cross product is directed along the z-axis. When A and B lie in the xz plane, the cross product is directed along the y direction. Another example of cross product of vector is torque. Torque is the cross product of the lever arm and the force applied to an object. Here is an interactive 3D visualization of torque in action. Depending on the direction in which the applied force acts on the wrench, the bolt is either driven into the block or loosened out. Mathematically, torque is defined as the cross product of the force applied to the object and the lever arm R at which the force is applied. Torque causes objects to rotate about an axis, just as applying force to the door handle causes it to swing open. The magnitude of the torque depends on the force, the distance from the axis, and the angle between them. Check out the fascinating world of spinning top in this 3D visualization where angular momentum, torque, and precision dance together to create a mesmerizing spectacle. For more, visit effectual.com and effectual.github.io for interactive 3D physics simulations. Thank you for watching this video. I hope the website complements your textbook resources and is useful and informative. The video just gives a glimpse of what is available at the website for you to explore. If you have any questions or if you would like to learn more, feel free to leave a comment below. Don't forget to like and subscribe for more contents.